investigate the types of story problems, aka word problems, and how to solve the problems. So here I'm gonna give you a couple of examples, okay? When I give you the word problems, I want you to put on first teacher's hat, two a student's hat. A student could be first grade or second grade student, okay? So think about two different strategies. As a teacher, how would you approach to this problem to solve? And then think about how your student, most common students, would approach to this problem. Number one, when Mrs. Jones's class went out for recess, the boys left 5 jackets and the girls left 3. How many jackets were left? Two, Jill and Jack want to add their money together to buy their mom's birthday present. Jill and Jack want to add their money together to buy their mom's birthday present. Jill knows that she has $15 but doesn't know how much Jack has. The total of their money is $33. How much does Jack have? How did you solve these problems? Is there any difference between the teacher's approach and a student's approach? What did you notice? What could be common mistakes that students make when they solve this problem? I want you to consider that, okay? So pause the video and take a few minutes to consider that and replay this. So when I was reading these two problems, I emphasized intentionally some words. Like in the first problem, I emphasized left, left, and left, right? Because with those words, a lot of students can get confused. This is a subtraction problem, and they may just subtract 3 from 5. But actually, it's not the right answer, right? How about here? I emphasized add, together, total, those words. Because these words, add, together, total, if we say that it is a keyword, we get to just add these two numbers together. That's the common mistakes that students make. So, I'm going to talk about the misleading operation here. 2 common classroom practices that mislead students and hinder their true understanding of the operation are these 2. Using keywords. They think that helps students identify the operations, but not really, as we saw in these 2 examples. In this question, even if it was left and left, we actually had to add these 2 jackets together, right? That's how many jackets were left in the classroom, 5 plus 3, so total 8 there. But by just looking at those keywords, students can get, confused. Same here. They may think they have to add these 2 numbers because they saw the words, keywords, add, together, total, things like that. But actually, you have to find the difference between these 2, right? So those are very common mistakes that students can make, because some teachers, hopefully you don't, some teachers say, look at the keywords, what operation you need to do. Well, actually, you have to look at the context, right? Second one, limiting our story problems to simple join and separate problems with an unknown result. We always think that the result is only the one that is unknown. But sometimes the start can be unknown, sometimes the change can be unknown, right? So we're going to talk about that here today. So word problem or story problems, you can think about that problem as a combining situation or separating situation. In combining or joining problems, two or more quantities are combined to form another quantity. So it's joining or combining problems because you are combining things together. For example, Ted had 6 marbles. Sophia gave him 4 more. How many does Ted have now? Regardless of the word more, we look at the situation there. Ted had 6 marbles. Sophia gave him 4 more. So they're combining these two groups of marbles together. So we're gonna count 6 and 4 together, right? So it is a combining problem. How about in separating problems? One quantity is removed from another. So we are separating two quantities, resulting in a portion of the original quantity. So this includes the familiar take-away situation. We are separating or taking away. For example, Ted had 10 marbles. He gave 4 marbles to Sophia. So he's taking 4 away. If you are using concrete models, you can show, right? You can show 4 marbles away from 10 marbles. You are separating those 4 marbles from 10 marbles. So situation like that is separating problems. And you can also consider what is unknown. Not always the outcome is unknown, but sometimes the start can be unknown, sometimes change can be unknown, right? So you need to consider what is unknown in this joining problem or separating problem. Some problem types are more challenging than others. You need to acknowledge that. Teachers should pose a variety of problem types so they get to, used to solve those problems, not just by looking at the keywords. Okay, I need to show you one mistake here. So when we are using the keywords like this, some classrooms have poster like keywords for subtraction, keywords for addition, and putting sign like this, and they think it's very, very useful, but sometimes it misleads the student's solution. Keywords for addition, add, increase, combined, together, plus, both, total, in all, sum, or together. Yeah, that indicates it's addition problems? No, that indicates it's joining problem. Okay, how about these? Keywords for subtraction. So putting a subtraction sign there and putting all the words like how many more, decrease, take away, minus, less than, difference, fewer. What does it say? How much more remains? Some of these like that is comparison problems, but like how and this too. And other things, it's like take away model. Okay, separating. So, but sometimes you have to use addition operation to solve that story problem. Okay, so keep that in mind, and you need to emphasize to your students that don't rely on to only the words, but you need to look at the context. Okay, and let's go back to this problem, these points that I made. So the last one here is children don't always solve them in a predictable addition versus subtraction way, but that's okay. And they can make different strategies too, and that's also okay. And we actually welcome that. We appreciate that more ways of solving, because students can connect their idea with the different people's idea, and they can see how the math topics are connected to each other. Okay, so let's try a couple of problems here. When I give you some examples here, I want you to consider whether it is combining or separating problem. Okay, and also in each combining or separating problem, you need to also identify whether it is start unknown, change unknown, or outcome unknown. Okay, so first, Sandra had 12 pennies. She gave some to George. Now Sandra has 8 pennies. How many did she give to George? what situation is this? Is this combining or separating? She gave some to George, so it is separating. And let's take a look at this. Sandra had 12 pennies, so that is a start. She started from 12 pennies. That's a start. She gave some to George. That sum is the change. That is unknown. Now Sandra has 8 pennies. Outcome is given to us. So we know the outcomes, but we don't know the change. So in this word problem, we get to know it is a separating problem with change unknown. Take a look at this. Similar problem, but maybe it's a little bit different from the first. And I will read it, and you need to consider whether it is a combining or separating, start change, or outcome is unknown. Okay? Sandra had some pennies. George gave her 4 more. Now Sandra has 12 pennies. How many pennies did Sandra have to begin with? You got that? It's again separating problem, isn't it? Because Sandra, oh no, actually it's a combining problem. So even if it says gave her or gave some to George, it sounds very similar, but this was a combining problem, but this one is, I'm sorry, this is separating problem, but this is combining problem. Right? Sandra had 12 pennies. She gave some to George. She gave away, so it's a separating problem. But here, Sandra has some pennies. George gave her 4 more. So we are combining some with 4 and have outcome as 12. So we don't know what the change, what the start is, but we know what the change is, and we know what the outcome is, right? So in this problem, it's combining problem with start unknown, right? So that's what you're looking for. Okay. To solve these problems, you can have a lot of different models. Problem is using models like counters, right? So think about the first problem. Sandra had 12 pennies. She gave some to George. So let's suppose this is Sandra's pennies. You can represent with concrete models like this for your students. 3, 4, 5. I love 10 frames, so I'm gonna arrange these similar to 10 frames. Okay, so 7, 8, 9, 10, 11, 12. So maybe I can put a space there. So 12, that's how many Sandra had. Okay, so 12 pennies. She gave some to George. Now Sandra has 8 pennies. 8 pennies. So we can separate this, right? Because now she gave some away and has only 8 left. So this much is Sandra has now. So we can separate them. So you can see that, oh, that's a separating situation. And how many did she give to George? How many did she give to George? This is how many she's gonna give to George, right? Because this is how much she has left. So 4 is the answer. So something like that. You can use actual counters or actual pennies. There are a lot of things. Or if you remember from Singapore math in the previous lessons, we can also draw bar models too, right? So let's think about Sandra's 12 pennies using bar model. So let's suppose this is 12 pennies. That's how much Sandra had. She gave some to George. We don't know how much she gave away. For your younger students, you can just put a question mark or you can put a blank and let them find it out what it is. For advanced students, you can use, variable like X or A or whatever letter you want to. And now Sandra has 8 pennies. So this is how much she has now after giving this part away. So separating this from this, right? And what is that? they're gonna do 12 minus 8 to find that. So even if this sounds like, joining problem, because it says she gave some to George, it's kind of confusing. But by looking at actual model like this, we get to know what operation we have to use. Okay, so how about using number line? We can also think about using number line, right? So Sandra had 12 pennies. We can go all the way to 12. Oh, here's another thing that I need to mention about students' common mistakes. They have to start from 0 to go to 12, right? But sometimes they make mistake like they start from 1 and go to 12. This is actually 11 skips. So be careful, students, not use this kind of mistake, okay? So they can hop to 12, showing Sandra's 12 pennies. And then she gave some to George. I don't know how much. But now she has 8 pennies. So what happened here? Since we went back to the left, we know it's gonna be minus 4. So taking away 4, separating 4 away from 12. Okay, so we can use some, models like that. Okay. Okay. This problem, well, I will just leave it here. I don't think we have enough time for you to do that, and we have no interaction here. So rather than I put more examples here, look at the homework part 1. Okay, you're gonna use this table. So you are given, some word problems, sets of word problems. You need to sort them out and determine whether it's a combining problems or separating problems. If it is combining problems, is that start unknown, change unknown, or outcome unknown? If it's a separating problem, is it start unknown, change unknown, or outcome unknown? You have to do that, and the description is given in the homework, so take a look at that. Another way of looking at the problem, word problem, is part, whole problem. And this, just like very similar to our separating and combining problem, you can take a look at what is unknown. The whole is unknown or a part is unknown, right? So for example, George has 4 pennies and 8 nickels. How many coins does he have? What is unknown? The total. The total is unknown. He has 4 pennies and 8 nickels. So if you are using counters like that, you can have 8 pennies, 1, 2, 3, 4, 5, 6, 7, 8. So the red counters represent pennies, and yellow ones, I can represent nickels with it. Oh, actually I had 4 pennies. So let's say this is nickels, okay? Red one's nickels, because in the question it says George has 4 pennies and 8 nickels. So that's 8 nickels. And let's say this is 4 pennies. 1, 2, 3, 4 pennies. 4 pennies and 8 nickels. How many coins does he have? Well, these are all coins, whether it's nickels, pennies, or nickels. So together we can join them together, right? Together as the whole, we get to know total is 12. So we have a part, one part as pennies, another part with nickels, and we are looking for what is the whole thing, right? That is part, whole situation. Okay, and how about this one, part unknown? Here's one example. Excuse me. George and Sandra put 12 pennies into the piggy bank. George put in 4 pennies. How many pennies did Sandra put in? So we can maybe draw a picture like using bar model. Then how can we do that? So we can consider this problem as George's and Sandra's. But total is, it says, George and Sandra put 12 pennies into the piggy bank. So total is 12 pennies. Altogether is 12 pennies. George put in 4 pennies. And Sandra put some, but we don't know how many Sandra put in, right? So we can put it as a blank and students can find that. So 4 and what makes 12? Again, there are a lot of strategies to find this. Some students already know 12 minus 8 is 8. 12 minus 4 is 8. But some students can use the counting skills, like counting on, so they can go, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, I had counted 8 more, so that's 8. It's okay that they use the counting skill, right? They can gradually develop their subtraction skill later, but they get to know it is part, and whole situation, and they have to find the part. Okay, so that is an example for a part, whole. And lastly, you can do what is the difference between part, whole, and join problems. I didn't put an example there, but when you are given 2 parts, you can find the difference between those two. Of the story problems in addition or subtraction, we can think about compare problems. So in compare problems, you can think about the difference is unknown, larger is unknown, smaller is unknown. So I'm going to give you a couple of problems with George and Sandra's pennies and nickels again, okay? So the first one, George has 4 more pennies than Sandra. George has 4 more than Sandra. What is given to you? Difference is given to you, right? And it says George has 12 pennies. How many pennies does Sandra have? George has 4 more than Sandra. So we know George's 12 pennies is a larger part, right? So we know that is known, and difference is 4, so that is also known, but smaller is unknown. Sandra's money is a smaller amount, and that is unknown. You can use the bar graph and make it differently. So George's can have bigger. Let me actually show you. I know you guys know how to do that. I just want to show you. Okay, so for that example, we know George has 4 more pennies than Sandra. So George's pennies is 4 more. 4 more, that's what George has. How many George has, right? And we know this much will be then how much Sandra has. Because Sandra has, George has 4 more than Sandra. And next sentence is saying George has 12 pennies, but the total is George's pennies is total 12. So to reach the 12, we can find that unknown. What is that unknown? It's larger that is a larger part, and that is a smaller part. That's smaller unknown. So when you are drawing actually differently, you can have 2 larger and smaller. I think it makes more sense. So you can have 2 larger and smaller bars, and larger one is George's, and we know there are 12 pennies as a total, and he has 8 more than Sandra's. So 4 more than Sandra's, so that is 4 more. Then you can compare the length here with this and say how much is here is the same as how many Sandra has here, right? These two are exactly same amount, and students can find that as 8. And that is compare problem where smaller number is unknown. Okay, let's look at the next example. George has 12 pennies, Sandra has 8 pennies. How many more pennies does George have than Sandra? We still know that George has more, right? But in this case, let me see. Let me look at this one. Okay, so George has 12 pennies. This is George's 12 pennies. And Sandra has 8 pennies. So we are given larger number and we are also given the smaller number too. And the question is asking how many more pennies? How many more pennies? So we are looking for this amount. How many more pennies does George have than Sandra? So what is unknown? The difference is unknown. So in this case, you are given the larger number, smaller number. So you need to find the difference, and difference is unknown. Okay? All right. Oops, what am I doing? Sorry, guys. Okay, so here is the chart that you can use with 4, 8, and 12. And here we're going to talk about computational and semantic forms of equations. So when you have joining problems or separating problems, you can see the result is something that you have to find because that's unknown. You can put a join problems like a plus 4. You can do a plus 4 equals something. That result should be 12. How about separating problem? Something minus something will be something, right? In separating problems, you can do either 12 minus 4 is equal to unknown, or you can 12 minus 8 is equal to unknown. So always that result is unknown in this case. How about change is unknown in join problem? So if we are using the same thing here, and if we are using the same thing here in here, let's do that again. Using this, we don't know what the result is. So we don't know what the result is 8. You need to find that. So separating problem where result is unknown, you can do 12 minus 4 is equal to unknown variable or unknown quantity. And you can find the answer as 8. In join problem, the result is unknown, right? How about the change is unknown? This is the start number, that's the change number, that's the result number. So we can put the first number as 8 plus change, that's unknown. So put a blank, is equal to 12. And you're finding that change. In separating problem, you can do 12 minus change. So that's the start number minus change, unknown change is equal to result. So here, change is unknown in separate problem. Let's make start problem with a start unknown with a join problem. Start is unknown, so unknown plus 4 is equal to 12. And you can find that unknown value there. In separated problem, start is unknown. So start is unknown. You're separating some number like 4 and the result is given. So it is 8. So you can fill in the chart, right? So I want you to complete the chart in your notebook. And let's move on to this. I highly, highly regard the equal sign. And I want you to do that too. Because there's a lot of misconceptions about equal sign among the students and sadly among the teachers too. Okay, so I'm gonna give you one problem here and think about how would the students write their answers to solve this problem. And I want you to try this too in your notebook. Start with the 7 marbles, add 3, then subtract 8. To answer this, how do you think students would answer, would write? The common mistakes they do is, it says start with the 7 marbles, add 3, that's 10, subtract 8 equals 2. Yes, the answer is right. But is this really right? I want you to pay attention to what's going on here. Look at the equal sign. What does equal sign mean to you? What does equal sign mean to you? It can mean as, operation, but that's not the only meaning of the equal sign. It has to be balanced. So think about the balance. Equal sign means it has to be equal. Whether you put 2 blue balls there or 2 white balls there, the weights are the same. That's same as equal sign. These two are equal then. So you need to look at both sides. 7 plus 3 is 10, but look at this side. 10 minus 8. That's 2. They are not equal. You cannot put equal sign there. But students do run on a lot of times like that. And some teachers do the same mistake too. So I want you to be careful. How about this way? 7 plus 3 is equal to 10. And I subtract 8 from there. That's 2. So the final answer is 2. What do you think? This is okay because this is not actually equal sign. It just shows the result after that operation. So after this operation, you get 10. After this operation, you get 2. So it is okay. But for equal sign means both sides have to have exactly same quantity there. Okay, so pay extra attention there. All right. Okay. So some mistakes that students can have is this. If they are given problem like what goes in here in the blank, guess what the mistake they make? Not all, but some students can make a mistake like 4 plus 3 plus 2 is equal to 7, 8, 9. 9. Then add 2 and put equal and put 11. But not really. What goes in here? It has to be 7. Because 7 plus 2 is the same as 7 plus 2. 4 plus 3 is 7. So 7 goes here. Right? So equal sign can mean result of performing an operation. Yeah. It can be decomposition, like the second one. So 7 can be decomposed as 4 and 3. Right? So that's the second meaning. Also, it's equivalent value of two operations. And then so on and so on. A lot of things. But I think the scale with balance explains a lot better for equal sign. So keep that in mind.